Hi, my name is Ian Partridge and I'm a member of the IBM Java support team. I'm here today to give you a very brief introduction to some of the performance improvements that Java applications running on the IBM Java runtimes can realize by using the shared classes technology features which are built into IBM's Java offering. So what is shared classes? Well, it's a feature built into the IBM JVM which offers you a very easy way to both reduce the virtual memory footprint of your application and also to improve the JVM startup time. And I'll talk about those two improvements and how you can realize them. The feature allows you to create what's called a cache, and then different JVMs can store and share data in that cache. The idea behind it is that if you have more than one JVM running simultaneously on your system, then those two JVMs can share the data in the cache, thus avoiding duplication and saving the resultant memory costs. The cache can also be reused by future JVMs. So if one JVM shuts down, then the next one to be created can, instead of having to create all the data that's in the cache, it can reuse what's in the cache already, and thus the startup time can be improved. We store various different types of data inside this cache. In Java 5, the first IBM Java release to feature the shared classes technology, we stored just class data inside the cache. This already gave substantial performance and memory footprint improvements because modern Java applications typically load many, many thousands of classes, and being able to share that data was a big win. However, moving on to the future, in Java 6 we released improvements to not only store class data but also to store AOT data and shared string data. AOT stands for ahead of time, and this relates to data used by the JIT compiler. So when Java methods are compiled at runtime to native code, we're able to store some of the resultant code inside the shared classes cache. Obviously, this means that next time we don't have to generate that code at runtime again. Another thing we store in Java 6 is shared string data. It turns out that a lot of the memory used by Java applications relates to strings. So by sharing that data, we're able to reduce the costs and save virtual memory. So here's a simple picture of what the shared classes system would look like if it was turned off, so in a normal Java application. You can see that we've got two JVMs, JVM1 and JVM2, and each of them has their own copy of class data and AOT code. They're operating completely independently, and the result of that is that we have duplication in memory. The memory usage of the application will be higher than it would be if the two different types of data could be shared between the JVMs. So moving on to the next slide, you can see here this is what happens when shared classes is enabled. What happens is we have one copy of the data, the class data and the AOT data. That's the shared cache you can see at the top. And then each of the two JVMs, JVM1 and JVM2, then maps that shared cache into the memory and has its own private copy. Because there's only one copy of the class data in RAM, both JVMs are referring to the same memory locations, then that means that the memory usage associated with class data is half the size that it would have been if each JVM had its own independent copy. This also has the advantage that since we're sharing AOT code as well, that AOT code is already available when the next JVM starts up. So it doesn't have to be generated at startup time, which means that the startup time of the JVM can be substantially reduced. So what is the cache itself? How does it operate? Well, it depends on what operating system you're running on, but it's either an area of shared memory, that's on ZOS, or a memory mapped file on other operating systems. So if it's shared memory, then that's implemented using standard Unix IPC shared memory. If it's a memory map file, then that's a physical file on the hard disk the machine, and as the JVM wants to open the cache, it opens the file and maps it into memory using the standard memory mapping APIs available on each operating system. For the classes that we share, we allow all application and Bootstrap classes to be shared by default. By Bootstrap classes, I'm referring to those classes which are part of the Java class libraries, which are automatically loaded when an application starts up. I said earlier that shared classes allows you to realize startup time improvements because the cache can be reused. The reason the cache can be reused is because it is persistent. Once all the JVMs have finished accessing the cache and have disconnected from it, the memory map file still remains on disk, so that if a future JVM starts up again, it can reopen the file, reconnect to it, and carry on using the data that was stored in it last time. That's optional though if you want to configure the cache to be lost when the last connected JVM disconnects, then that option is available. Any JVM can create a cache, and any JVM can connect to the cache. We don't have a concept of master-slave or an owner over the cache. It's whoever happens to create the cache first does, and anyone else then connects to it and uses it, and they aren't aware whether the cache was created by them or previously. There are no restrictions on which JVMs can share a cache. Any JVM on the machine running any application can connect to the cache. The exception being if there's some sort of runtime bytecode modification going on, perhaps via a JVM TI agent, where there's special considerations there, which you can read more about in the documentation. And it's important to realize that the whole feature is transparent to GC, so things like dynamic class unloading all still work as you would expect. The feature's been designed so that you should be able to turn it on and forget about it. The cache dynamically keeps itself up to date, adding classes to the cache as different classes are loaded, adding AOT data to the cache as new methods are compiled. And the cache will dynamically keep itself up to date. So you can enable shared classes by using the simple command line option on the IBM JVM, and that option is -x share classes. There are lots of subcommands to that which are available and fully documented, and these subcommands allow you to perform what's known as utility functions. So, for example, there are utility functions to list the caches that are available on the machine, find out which Java levels they're compatible with. You can find out details about each cache's occupancy, how full it is, and you can delete ones which you no longer need. When you create a cache, you have to choose what size you want it to be, and the way to do that is using the -x scmx option, which allows you to specify a size. As I said, JVMs can either connect to an existing cache or they can create a new cache. The way that caches are identified is via their name. So you could say -x share classes and then name equals mycache1, for example. And there can be multiple caches on the system, but each JVM can only be connected to one at a time. So the way it works is when a JVM decides it needs to load a class, the first place it will look is in the class cache to see if the class is already there. If the class is found in the cache, then the class is loaded directly from the cache to avoid going to disk. Obviously, disk access is much slower than reading from a memory mapped file. Otherwise, the class is loaded straight from the disk, which is slower, and then the contents of it will be added to the cache once the normal process of class loading and class verification has occurred. There's no restriction on class path, system properties, or VM settings. As I said earlier, the feature has been designed to be as transparent as possible to Java applications. And multiple JVMs can concurrently populate the cache. So So for example, if you start up 3 JVMs at the same time and each of them is loading classes, the system will manage access to the cache so that each of those JVMs can add the data and read data as required from the cache. I said earlier that all application and Bootstrap classes can be shared. That's true, but it's important to realize that custom class loaders can't automatically share. What we do is we provide a Java API and documentation for that for integrating your custom class loaders. So if you've extended Java Lang class loader yourself to implement a custom class loading framework, perhaps using OSGI, then you should look into using that API in order to do custom sharing of those classes. So that's been a very brief introduction to the shared classes feature. If you're interested in learning more, I've put 3 links there. 2 of those are to DeveloperWorks articles which summarize the technology in some detail. And the last one is to our diagnostic guide, which contains full information about all the shared classes options and also some information on debugging different problems that you might see with using shared classes. I hope you've enjoyed the presentation, and thanks for listening.